Hello everybody. Welcome to SolidWorks Modeling Learning Assignment number 3. In this SolidWorks Modeling Learning Assignment, you are going to be building a simple hinge. We will be using the sheet metal function in SolidWorks, mostly to showcase that it exists, and it can be kind of useful anytime you're making something out of sheet metal. SolidWorks has some really neat features when it comes to converting a drawing directly into manufacturable product. Oftentimes it's assumed that you can just solid cast something or come up with a mold that would be able to produce this piece, either doing sand casting or through traditional molding processes. So if we instead use SolidWorks to create sheet metal parts, this would be as if we were able to stamp and use sheet metal parts directly. So kind of just showing one of the unique facets of SolidWorks here. So with that as an introduction, let's go ahead and jump in. So I've got SolidWorks loaded up this time. We will go ahead and start by creating a sketch. So here I hit create sketch. I'll go ahead and sketch on the top plane. Now what we'll be doing is we're going to be creating a 3-fingered hinge. So it's got 3 fingers on one side, 2 fingers on another side. We'll be modeling that in SolidWorks, and typically what you would do when you make a hinge is you would actually stamp it out of a sheet metal part. You would stamp it and then roll one of the edges to create the actual hinge. So we're going to be simulating that with what we're doing here. So to start, we have our sketch began. I'm going to go ahead and move over a little bit. I like sketching in relationship to this origin. What I will be doing here is I'm going to draw a rectangle quick, or maybe not quick. I guess that's touche, SolidWorks. Oh, click the smart dimension line. I'm sleep deprived. Okay, so now I drew an actual rectangle. I'll hit escape to get out of there. You'll notice rectangle comes in with auto constraints: vertical, horizontal, vertical. What I'm going to start by doing is I'm going to select this midpoint here. So I hover over this line around the midpoint, and then that point just automatically appears. You'll notice my cursor, there's a point that appears next to it. So I'll go ahead and click that, and then I will shift click the origin. So now I have 2 points selected. One is the origin, one is the center point, and I will go ahead and make those coincident just to lock that in place. This will effectively center my object at the beginning of the curl for my hinge. So now what I need is I need to create 3 hinge pieces. And this is kind of an interesting piece. You'll notice I haven't added any dimensions yet. I'm just going to draw three rectangles starting at this line, ending over here. Okay. There we go. Now this is the basic shape of what I want my hinge to be. Now, when we're going to be using proper SolidWorks techniques here. In good SolidWorks, you can just take Smart Dimension and sit down and dimension every single one of these lines. You can, but that's actually not good practice when it comes to SolidWorks. Better practice is if we create relationships. As we build this, we may or may not need to come in and fix some of these, and I would rather not fix them if I don't have to. So first off, we know that we have 5 pieces to the hinge. We have 3 fingers on one side and 2 fingers on the other side, which means we have a total of 5. And that total of 5, they're all about the same distance. So whatever height we make this, we're going to have to divide it by 5 and that will be the width of each of these boxes. To start out with, I'm going to go ahead and click Add Relations. It's going to drop me out of my Smart Dimensions. This is just another way of adding relationships between things. I'm going to take the top line of each of these, add them all together, and make them all equal. You'll notice that they're all horizontal, which means they're all already parallel. If you hit collinear, they will all suddenly be on the same line. If you hit vertical, it will break it because they're all already horizontal. Don't use the fix button. It's just bad practice. Equal makes them all equal length. So you'll notice they're all equally sized there. I'm going to go ahead and hit OK for my add relation. The other way of adding relation is if I just hold down Shift and click these three lines, you'll notice that it brings up a Properties tab, and in that Properties tab I can add relations here. Now the three Properties tab that I have are, you can make them all intersection. I don't really want to do that. This isn't always as clean of a route of going when it comes to adding relation, especially when you're trying to do it with three objects. So I'm going to go back in here, go to Add Relation, select this one, and I'm not having to hold down the Shift button here. You can just click the lines when you're on the Add Relation one. And I'm going to go ahead and make them all equal. So now they're all equal. If you wanted to do it with a Properties tab, you can do it, but you can only select 2 items at a time. So now you'll notice that I am unable to stretch one of these without all 3 of them reacting. Okay, that's kind of nice. In order to make this really, really nice, I'm going to go ahead and draw 2 more lines. One from here to here, and one from here to here. And then I'll hit Escape to get out of the line. I'm going to click on this line, go over here, and the line property shows up on the left. I'll click For Construction. I'm going to do the same thing for this line up here. For Construction. You can actually set that as a setting when you draw the line. But now I have these 2 construction lines. What I'll do with these construction lines is I'm going to add a relation between these and this other line up here too. So we'll go up to Add Relations one last time, and I will select these 3 lines, one of the 3 fingers, and those 2, and then I will make them all equal. Okay, and there we go. Now you'll notice, I'll hit OK. Notice this line, I can't actually move it up and down. It is fixed with this point right here, and it's horizontal. I want to do that down here with these 2 points too. So I'm going to go ahead and select this point. You can go into Add Relations, select these 2 points, or I just select that point, Shift, click on this point, and I'm going to hit Merge. Now it's going to force those 2 points to be together. So now I have 5 equal spaces, your 3 fingers and then your 2 other spaces, and it's all going to be where if I make this hinge larger, it's going to automatically increase the size of these 3. Okay. Now I haven't had to use any dimensions on this yet, which is really nice, because you don't want to have to use dimensions if you don't need to. That just makes things a little simpler. So now with this, I have my 3 fingers. I'm going to go ahead and add some dimensions. Actually, before I do that, I'm going to trim. So I will go to my trim entities. I'm going to go in here and I'm going to just wipe out this line, and this line. And hit OK. Now you'll notice here that the moment I did that, it kind of broke my connection to the origin. I'm going to go ahead and try to set the origin horizontal to this point. So I will click that center point, Shift click this center point. These will be horizontal, so it'll be right in the middle. And then I will hit OK. And then we'll click this point, Shift click, hover over the origin until it gives me a point, Shift click the origin, and I will make this vertical. and hit OK. If I try to make it coincident, it would have broken SolidWorks right there. Alright, so now I have this really fun E. That's nice. What I'm going to be using for a pin here is I'm going to be using a 1/4 inch pin. 1/4 inch pin, and it's going to rotate around about 300 degrees, maybe about 320 degrees. So I'm going to pop up my calculator real quick. I need to know what the circumference of 320 degrees of a circle of inter diameter 0.25 inches is. So here, 0.25 inch diameter, you know that the formula for a circle circumference is 2 pi r, or pi times the diameter. That is true when it goes all the way in a full circle. Here, we're not going in a full circle. This is actually only going 320 divided by 360 degrees on a full circle, which is 0.8889% of a circle. So I'm going to take 0.8889 and I'm going to plug that in my calculator now. So it'll be pi times d times the percent of the circle. So 3.1415 times, I have a 0.25 inch radius diameter, and then I'm going to multiply it by my scale factor. So here I only need this to be, the finger length to be 0.6981. I'll round that up to 0.7 just for simplicity's sake. So I'll go to my smart dimension, and I'm going to dimension this line, and this will be 0.7 inches. Okay. Now you'll notice that SolidWorks gets a little freaked out because I just finally added a dimension and it's trying to figure out how to handle that. Let's go ahead and make this height here. We'll say that this is 4 inches. The whole thing gets huge. Oh man, that's screwed up. So here, this point here, there's no going back and saving this. I'm gonna escape out until I can click on this dimension and just delete it. I don't want it anymore. It's a pain in the butt. I will dimension this one here, and this will be 0.7 inches. That point there is going to cause me problems. I'll have to fix it. Yep. You are going to cause me problems. And I assume that the one on the top is going to cause me problems as well. Well, shoot. I'm going to hit escape. Grab this point, drag it back here. This point is vertical there, which that's helpful. I have to do the same thing with this one. I'm going to click that point. I'm going to click this line, and I'm going to make it not coincident. I'm going to have to go ahead and add a relation. So here, point, vertical, hit OK. Point, vertical. All right, that way I just don't have to define the distance. Now I want to define this distance right here, which is the box distance. I'm going to make this half of that 4 inches. So here, well, I'm going to make it half minus a little bit more. So this one will only be 1.5 inches. Okay, so there's my hinge. Now you'll notice all of the lines are black. This is fully defined. I can go ahead and exit my sketch and be done with this. Okay, yay hinge. Now, normally we would go to features, do an extruded boss base, but instead what we're going to do is we're going to be going into sheet metal. And I'm going to create a base flange / tab. So here, There we go. We'll go ahead and we'll just set the sheet metal property. We'll say that this is about 1/20th of an inch. So I'll set that to 0.05, hit enter. You'll notice when we zoom in on this that it is extruding upward, or no, it is extruding downward from this. We'll say that that's okay. K factor is how much it allows for bends. This is going to be set for the pretty much the whole part. And I don't really use the rest of these features. You'll notice you have the option to use a gauge table. If you're working with a very specific gauge of metal, sometimes that can be helpful, especially when you already have those libraries. Those libraries do exist, but we're not going to play around with them today. So I'll go ahead and hit OK. And now you'll see that we have a solid. Now, because we made this out of a base flange, this actually has different properties than if we were to just go in here and do an extruded boss. Because now we have all of these other features that we can use too. Things like flatten, which would give us the actual pattern for what we're trying to cut. And things like corners, you can create lofted bends. There's just a whole lot. What we're going to be using is we're going to be using the hem feature. We're just going to be curling this edge. So I'm going to click the top edge here. I'm going to click the top edge here. And I'm going to click the top edge here. Okay, so those three edges will show up. I'm not going to change that parameter here. I'm going to go down to type and size. If you did a closed, it'll take it, it'll stamp it, and it'll smash it together. Okay. Here, this is an open one. That wouldn't really be very helpful for a hinge, because if you're trying to do something that has a full 180-degree bend and that has a piece on top of it, 0.5. Okay, you could do that. That would be acceptable. I don't want to. I want to go in here and I want to do a rolled end. What this rolled end does is this allows us to have a hinge that goes in between it. So I'm going to hit 0.25 and I'm going to have it go through an angle of 320 degrees. Okay, if you zoom in on the side, there's a little bit of a gap there. That's actually okay. You don't want to have you don't want that to be terrible. I just realized I did not need to make those 3 fingers. Good job, me. That was unnecessary. I'm actually going to go back in and change those dimensions now that we're done. Here, K factor is set at 0.5. That's just because that's the material type that we're using, and there is a tear relief. So I'll go ahead and hit OK. So that now is what our hinge looks like. I'm going to go back and change this from 0.7. I forgot you didn't have to do that. Go back in here. And I'm going to say, well, basically what I want is I want half the distance here. And I'm going to have to change that from 0.25 because I broke that one too. I want this to only be ½ an inch. I have to go ahead and change my drawing itself. So I'll go back into my sketch, hit edit sketch, change this distance now. Actually, I'm going to change this to 0.25 and hit OK. It'll look real short. That's okay. So I exit sketch, it'll rebuild. I'll want to stop and repair. It's going to pop up some error messages. Unable to insert the hem feature. So I'll just have to remake the hem. Yes. Okay, so remaking the hem. Select this one. Oh man. I'm gonna escape out of this. Apparently I just broke it all. I should not have made that shorter. So now I'm Control Z, Control Z, Control Z. I'll change it back to 0.7. Control Z, Control Z, exit the sketch. And there we go. I am going to go back in here and check to make sure that this is a 0.25 inch. Oh, that's a radius? Yeah, we'll set this to 0.125 for the radius, because I only want a 1/4 inch gap on the inside. We'll hit OK. Now you notice that we did something wrong with our math. Not sure what, but it appears that this is much larger than it needs to be. So I will go back in here, edit the sketch, and I'm just going to drop this down to 0.35. I think I made it twice as big as it needed to be. Hit OK. Exit sketch. It'll rebuild. Shouldn't give us any errors this time. There it is. That's what we wanted. Okay, so there's our hinge. Now quickly we have to give a set of holes. There is something called a hole wizard, which can give you predefined holes. Here in a lot of hinges, what they'll have is they will actually have a chamfered edge. It's this one right here, a countersink slot. It's going to ask what type and what size. Typically we'll say that this one's going to be a 1/4 inch. And then what it wants us to do is it wants us to define positions. Now we're actually going to have to draw positions on here. So here you'll notice this is our sketch. What I'm going to do is I'm going to draw some lines. So using this, I'm going to draw a corner here. Okay, so we got our 5 holes that we have to evenly space. I'm going to draw this one down like this. And draw it down like that. I should have set these to be center lines. Then I don't have to go back in later and set them to construction lines. Okay, I'm going to delete that line, so we only have this one. I'll take this line, hover over the center point, select it, shift select our origin, set those to be horizontal. We're just doing a sketch here. I'm going to set the dimension on this one. Let's see, the overall height on this is 4 inches. We'll say that the maximum distance we want our holes to be apart is just going to be 3 inches. Okay, and then we'll set the distance from this line to the outside edge. We'll set that at 1/2 inch. Okay. Now we're going to go ahead and draw another line, so I'm going to click on the line feature. Here, I'm going to start by drawing it as a construction line. I'll draw it down like this. So we'll have 2 sets of lines here. I'll go ahead and take this line, hover over its center point, click the center, shift click on the origin, have those be horizontal, hit OK. I have a smart dimension here. I had that one be 3 inches. This one, what that means is there's going to be 1.5 inches between the two of them. I will just have this one be 1.5 inches long. And then I will set this distance between that line and the outside edge to be 1/2 inch. Okay, now I hit OK. Now what we're going to be doing here is we're going to be identifying hole positions. So what we need to do is we need to sketch points. Here I'm going to sketch a point right there. I'm going to sketch a point right there. I'm going to sketch a point at the center line here. Decided to draw a hole over. Draw a sketch point right there. And I will draw a sketch point right there. And those are going to be my 5 hole positions. So I'll hit OK. And you'll notice that it auto makes the holes. Now I don't want them to look like those slots. So I will click on this and edit feature. Now we're just going to try to change the type of hole that it created. I don't want it to be a flat screw. I want it to be a socket counter screw head cap. I do not want any slot length. It's going to make me write 0.000, isn't it? Why are you doing this to me? I don't want... Close. Not 3/8. I want it to be 1/4 inch. Okay, so it's going to be a 1/4 inch. We'll make it close because that'll make it pretty tight. And then we'll hit OK. It's going to force me to have a slot. Okay. So there we go. I think a 1/4 inch might have been a little bit too big. So I will just quickly go back in here and we'll change that to a number 10 bolt. So again, the nice thing about SolidWorks is, oh, hold on, I have to make it to I wanted it to be a countersink. That makes sense. Instead of a 1/4 inch, I'll change this to a number 10 and hit OK. There it is. So that is now our hinge. Okay. So what I will do is I will go ahead and save this piece, and I'm going to call this one MLA 3. Hinge 3-finger. Okay. Now, rather than have to remake this, what I'm going to do is I'm just going to go ahead and take what I already have and kind of flip it. Instead of doing the hem on these 3, I'm going to go back to my original sketch, edit the sketch. I will orient back normal to my sketch. There we go. Okay. Keeping everything the same, I'm just going to change the lines a little bit. So here, uncheck for construction. And I'll draw this line here. I'll draw, this line here. And I will also draw this line here. Okay, that was weird. Oh, it's just showing the relationship. That's interesting. Now what I'm going to do is I'm going to change this one to be for construction. I'll change this one to be for construction. I'll change this one to be for construction. Pan down. I'll change this one to be for construction, and this one to be for construction. Okay, now I will select this line here, make it for construction, this line here, make it for construction, and then set this line here not for construction, and this line up here not for construction. Okay, now you'll notice what that does is by changing this one to construction, this one to construction, adding these 2 lines up here, what we've done is we've just changed our shape a little bit so that now we only are using the 2 interior fingers. And I didn't have to draw any brand new dimensions. I just used the existing sketch. Now, this is going to break our hem. So I'm just going to go ahead, jump in here. I should be able to delete this hem, but instead of deleting it, I'm just going to go to Edit Feature, And now it's deleted all of the edges out. So I'll just pick these two edges here and hit OK. Now, because there was an error, it repressed everything up to this point. I have to drag this line down. I'm going to drag it above the flat pattern, and this will just put my holes in. Oh, it's going to ask me to edit sketch 16 because something broke in this sketch. Here, I think not quite sure what this is. Oh, the distance value. Okay, so I'm going to delete the distance value and we'll put it back in. Okay, so distance here to here, 0.5, and there. Now we're good. We'll hit OK, exit sketch, and that resolved that error. And the error will disappear there. So now I have my second hinge, and I didn't have to do a ton of work to make that happen. So I'll go ahead and file. Make sure to hit save as this time because we're using our original part. This one's going to be MLA 3 hinge, and this will be the 2-finger. So I'll go ahead and hit save. Okay, now we have one more part that we have to create for our assembly, and that is going to be the hinge pin. So for this one, I can't just modify my existing hinge to get that. I'm going to have to create a part. So to do that, I'm going to go create a new part, hit OK. So pop up a brand new part file. We always start with sketch, so I'll hit sketch. To do this, oh, I'm trying to draw a circle too soon. I'm again going to draw on the top plane. Here I've got a circle selected. I'm going to zoom normal to this, and I will just draw a circle. Now here we're going to be creating a pin. So this is going to be a 1/4 inch pin. Oh my goodness, that is massive. I don't know why SolidWorks thought I wanted to draw that at 90 inches. Centered at the origin. We'll exit sketch. Now we will extrude this pin. Our total hinge height was 4 inches. So I'm going to go into features, extruded boss base. I've got sketch 1 selected already. If you didn't have sketch 1 selected, you'd have to go in here to selected contours and make sure you select sketch 1. Now we're going to be extruding it. Direction 1, we'll say blind. Blind just allows us to put in a direction, 4 inches, and OK. Alright, and we have one more piece to add to this. I'm going to go up here to this top. I'm going to add a sketch. It's going to ask me what plane I want to sketch on. Well, I want to sketch on the top surface here. You'll notice there's a new origin here. It's a projection of the origin. I'll draw a circle starting at that origin, drawing it out. So it's going to be slightly larger. The last one was 1/4 inch in diameter. We'll make this one 1/2 inch in diameter. And hit OK. It'll be too big to fit in the hinge itself. You'll notice again it's fully defined. We'll hit exit sketch. We'll go in here to features, extruded boss base, and we'll just extrude this up about 1/4 inch. We don't want it to extrude up 4 inches. It's a bit too big. And there we go. There's our hinge pin. Okay, so now we'll go ahead and file, save as. And this is MLA 3 hinge pin. Hit enter. Okay, so now that we have all of our pieces made, let's go ahead and assemble them into a full assembly. So I'll go into File, New, and instead of picking Part, we're going to go to Assembly. This will allow us to put our parts together. I'll go ahead and hit OK. Now the way that an assembly works is you have to start by putting in a base part, and then you add parts to it. The base part, when it gets put in, is put in as a basically a fixed piece, so it's assumed that it doesn't move, kind of like as if you're adding a ground. Then everything else is kind of put on top of that. We're going to make our base piece be the 2-finger hinge. So you'll notice we already had the file open. If you don't have it open, you have to click Browse, navigate to the file. But because I already had that one open, I didn't need to do that. Here I could just make the 3-finger piece be it. So I think I'll do that. There we go. I'll just put it down. And now this will basically make this be the ground for our assembly. So this will be the piece that doesn't move. Alright, now I can't really do a whole lot with this. So I'm going to go back into assembly and I'm going to insert components. I'm going to go ahead and start by adding in the 2-finger hinge. And then we'll add in the hinge pin later. Now, how do we get these pieces to come together? Well, similar to how we do in drawings, how we add the constraints in there, in the assembly they're referred to as mates. So a constraint, that add relations piece, here we're going to be adding mates. And mates are going to allow us to connect our pieces together pretty nicely. So I'm going to go ahead and click on mate. And now I have to find a way to connect this hinge to this hinge. Well, what I want is those hinges are rolled around a certain edge. I actually want the axes of those rolled hinges to be aligned. To do that, I have to go up to View, Display, Hide Show. And I'm going to turn on Temporary Axes just for a little bit. So once again, you go up to the menu option View, down to Hide Show, Temporary Axes. When you click it, you turn them on. We click out here. That's interesting. There's supposed to be a temporary axis in there. There was not. That's usually how I connect these. You'll notice that there is a temporary axis in here. If you wanted to mate screws to those, you can. These rolled hinges do not actually have temporary axes. Well, that's interesting. So, I wonder if it has a real axis? That's also a no. Huh. Okay, well, we have another route we can go. I'm going to leave temporary axes turned on just because that's what I'm used to. What I'm going to do is I'm going to mate edges together. So here, this edge here, which is the inner edge of this, it's circular. I'm going to go ahead and zoom out a little bit, scroll around, and I'm going to mate it to this edge here. Okay, we have a couple of different pieces that we can do. We can make them coincident, we can make them tangent, we can make them concentric. First off, I'm going to start by making them concentric. Okay, and now all that does, when I hit OK, is that says I want this hinge to rotate about the same axis as that circle is. Okay, whatever the center of that circle is, both of those centers are aligned now. That's what concentric means. The next step is I have to take this face and I have to stick it to this face, because that's how it works in a hinge. You don't actually have to do it for all of the hinge pieces. You only end up having to do it for one. So I'm going to hover over this face right here. Should turn orange on the edges. I click it, it says face 1. I'm going to scroll around and make sure I pick the right one. Here, this face here, I click this face, and then I want them to be coincident, and I'll hit OK. Now you'll notice that your hinge rotates and it doesn't fly away. You can make it rotate as much as you want. Okay, now we're only missing the hinge pin up there. So I'm going to go ahead and close out of the mate, and we'll add one more component, and this time it'll be our hinge pin. We'll go ahead and drop our hinge pin in here. Now I'm going to go ahead and add another mate. Here because I don't have the temporary axes, I typically prefer to mate axes. Instead, I'm going to mate the outside face of this. Oh, no, I'm going to delete that. So I click on that, hit delete. I'm going to scroll down and grab this edge, circular edge. I'm going to scroll up here and grab this circular edge. And I'm going to make them be concentric. Okay. Now I was really hoping that my pin would be on the other side. So thank you for that. But we'll go in and adjust that mate in a second. Here I have one more mate. I have to put this face, which is the bottom of this hinge pin. I'll click on that face. I have to mate it to this face over here. Now, this is going to kind of screw everything up. That's because I had it. One of my mates is the wrong direction. I'm going to have to go address that. So I'll close out of my mate. Now down here, this is your mates. This is all of the mates that we've added into the drawing are right here. This concentric one, this one is the one that's backwards. So I'll go in and edit feature. If we do it right the first time, it usually helps. And I'm going to change the mate alignment. So it's just going to flip it around. Thank you for mating, for reversing that mate alignment, SolidWorks. And then I'll hit OK. And so now I got my hinge pin over here. Okay. So there we go. There is our hinge assembly. We'll go ahead and finish this up. Close out of the mate. Go ahead and save this assembly. Usually you'll have to rebuild and save. All it does is it goes and checks the parts to see if the parts have changed. We'll call this MLA 3. We'll just leave it at MLA 3. Okay, so time to draw this and hand in the assignment. So we'll go to a new drawing file, hit OK. And here we're just going to put in first we have to navigate to our SolidWorks sheet. We're just going to put our standard 3 view in here, and we won't worry about dimensioning. Now this file was called MLA3. You'll notice right here this points out that it's an assembly, whereas these two are parts. So I'm going to grab this assembly, double click it, double click it. There we go. Put one here, put the top view, put the side view. Okay, not a very pretty view, but it does show all 3 of those pieces. I'll go ahead and hit escape. And then all we have to do is just add our properties into our drawing sheet and we are good to go. Alright, so we'll change this to being MLA3. Change the description to be hinge drawing. The date is right. We did use inches. I'll go ahead and hit OK. Here we'll go to File, Properties. Under the author, we'll change that to CJS. Those are my initials, so that pops in there. And now we have everything filled out for this drawing. Go ahead and File, Print. Microsoft Print to PDF. Current sheet, you can do all sheets. Hit OK. And then we'll save this as MLA3. And hit enter. All right, so make sure that you hand in your PDF